Good morning, and we're halfway through our program. We are on Course 1, Chapter 4, Practice Test. And it says to find the area of a parallelogram. Well, I know when I do the area of a parallelogram because that triangle right here, if I lifted it up and put it right here, it would make a perfect rectangle. So all I do is I take my length times my width, or in this case, height times base, and I get my answer. Exercise 2, we're looking at inches. So when we get done with our answer, it'll be square inches. And again, we're going to do our length times our width, or in this case, our base times our height, base being 7, and multiplied by 14, and that will give you your answer. And always we do length times width. So our length is 1, 2, 3, 4, 5, 6, 7, and our width is 3. 1, 2, 3. So length times width. So now we know when we take a parallelogram or if we take a square rectangle, our formula is length times width. But when we take a triangle, because we're only taking half of that area, we have to divide it in half. So you can see the triangle only takes up half of the area of the parallelogram. So we have to divide it back into half. So we take our length times our width, and then we divide it by 2. So for exercise 4, we're going to take our 8 times 9, which will give us our answer. Hopefully everybody here can do that. And then we're going to divide it by 2, and that will be our full answer. Next problem is also about a parallelogram or a square or rectangle being divided in half. So we take our length times our width and we divide it by 2 because there is our parallelogram. And when I put a triangle on it, it's only half of that area. So for problem 5, we're going to take our 10, we're going to multiply it by the 7, and then we're going to divide it into half, or divide it by 2, and that will give us our answer. Now remember, when you see this, this is not the same as when we take a square or a rectangle. What they're saying is from the bottom of this portion, or the bottom of this base, all the way up to the top is 10 centimeters. That's all they're saying. They're not saying we have to figure out this area here. All they're saying is that this height from here to here is 10. The base here is 7. So from this portion to this portion, so we multiply these two together and we divide by 2 to get our answer. Now the formula for a trapezoid is a little bit different. We take our top number, our top base, and we add it to our bottom base. And then you can see that little triangular area. We're going to divide that all by 2, and then we're going to multiply it by its height. So when we're figuring out the area for a trapezoid, we take our base plus our base, divided by 2, and we multiply it by our height. Now our base here is 3, our base here is 7, and our height total is 8. So we take our 3 plus 7, which is going to give us 10. We divide that by 2, which will give us 5. And we take our 5 and we multiply by our 8, and there's our answer. Okay, so for this problem, for exercise 7, you may look at this and think, that looks really hard. But remember what I've told you about the way that they're so kind to us in 6th grade. Whenever you see a fraction or a decimal, what they're doing is they're just making sure you understand how to add those together. So you have an 8 and a 2. I know that's going to equal 10. So it's going to be one whole. So we'll take a look at that in a second. And when I look at this at first glance, I think, why is this a trapezoid and not a square or a rectangle? Well, because up top, our top base is 5.8, but our bottom base is 6.2. So those are a little bit off. So we can't just take the 6.2 and multiply it by the 7. We have to use our trapezoid formula. So again, our trapezoid formula is base 5.8 plus base 6.2. So here's our 5.8 plus our 6.2, and we're going to divide those in half. So when we have it, our 8 and our 2, automatically we know that's going to equal a 10, or one whole. So I'm going to put it over here so I can see it. I'm going to use a 0 for my decimal, and I'm going to put a 1 over here. So 6 plus 5 is going to give me 11, plus 1 is going to give me 12. I can actually get rid of that 0 because I don't need it. Now I'm going to take my 12 and I'm going to divide it by 2, and that's going to give me 6. And now I just got to take my 6 and I have to multiply it by my height, which is 7. All right, so we're finding the area of a trapezoid, and this time what they've done is they've given us little squares. So remember, what we have to do is we have to figure out our top base plus our bottom base, divided by 2, and multiply by our height. So when we look at this, our top base, we're going to count over blocks. 1, 2, 3. Our bottom base, we count over blocks. 1, 2, 3, 4, 5, 6. Now we have to count from the top to the bottom or the bottom to the top, and we're going to count 1, 2, 3, 4, 5, 6 gives us our height. Just use your formula, you can do this. Okay, so this problem, oops, sorry. This is problem 9, and when I look right here, I can see how many squares are at the top, and then I need to find my trapezoid. And again, my trapezoid is my base, which would be 2 going across, plus my other base, which I'm going to count the blocks going across here, divided by 2. I take those numbers and divide it by 2, and then I multiply all of that by the height of this shape right here. And then I'm going to add it to my rectangle that's on top, and that will give me my answer. Go for it. Okay, so exercise 10 looks daunting, and we look at this and we go, ah, what do I do? Well, if I look at it really closely, I can almost divide a line right there, and I can see that this is almost the equivalent of a parallelogram. Let's take a look at a parallelogram and see what I'm saying. It's not almost the equivalent, it is. So here's the shape that I'm looking at, and our base or our length are 11 and our height is 6. So I'm going to go back and double check and make sure. And here's our base, it's 11, and here is our height, and it's 6. So I know the formula for a parallelogram is base times height, or length times width if I was thinking of a square. So I'm going to pick this up, and I'm going to do 11 times 6, and that's going to be 66. And again, I'm going to do 11 times 6, and that's going to be 66. And then I'm going to add these two together, and that's going to get my answer. So here we have a shape that looks almost like a house, the way we used to draw houses when we were little. And we have two shapes in it. We all know that this is going to be a square and a triangle. This is our square, and this is our triangle. And so we just have to plug in our two formulas. For our triangle, we do our base times our height, and we divide that by 2. For our triangle, or excuse me, for our rectangle or our square, we do length times width, or if it's a parallelogram, we do base times height. So we look at these two things, and then we add these together when we're done, and that gives us our answer because we're looking for the total area. So now let's take, so for our square, we're going to do our 9 times 7, excuse me, our rectangle, we're going to do our 9 times 7, and we'll write that down. And then we're going to have to do our 9 times 8 divided by 2, and that's going to give us our triangle area. Then we take those two areas and we add them together, and that gives our total square feet. Exercise 12 is asking us to plot them, and the first number is 1 and 4. So we go to our x-coordinate first, our x-axis, and then we go up to our y-axis, and 1 and 4 would look like that, and then we just plot the rest of the numbers. So for the next one, it says the vertices are rectangles are 3 and 7, 6 and 7, 6 and 1, and 3 and 1. Find the perimeter of the rectangle. So I'm not going to do this exact number for you, but I am going to show you. In the event that they do not give you the grid, let me show you what you can do. There's nothing to say you can't do this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Okay, so let's say the plotting is 2 and 4. 1, 2, 1, 2, 3, 4. Okay, let's say it is 2 and 2. So I go over 1, 2, 1, 2. And let's say the next part of our rectangle is 5 and 2. I count over 5. 1, 2, 3, 4, 5. And I go up 2. 1, 2. And let's say it's 5 and 4. I go over my 5 and then I go up to my 4. Now what I have to do is I have to count the distance. Okay, so for here, I go up 1, 2, 3. Another way to say it is 5 take away 2 is going to give me 3. So my top and bottom base are going to be 3, or my length and width are 3. And then I'm going to count up. Well, if I go up here, it's 1, 2. So this piece right here is going to be 2, and this is going to be 2. If I'm doing my perimeter, I know that I have to add all my sides together because it's 2L plus 2 width. So, or I can multiply 2 times 2 is 4, and 3 times 3 times 2 is 6. So, and I could do that, or I can just walk around and add them all together. And then my length times my width is going to give me my area of my rectangle. Okay, so this is the same question as we just did, except for instead of, being smaller numbers, they're giving you 20 and 40. Just think of it as 2 and 4, and then just go accordingly. Don't get all worried because they have it's a 20. It's not a big deal. Just do 20 and 20. Well, 45 and 45, 40 and 40. So just choose and put your little numbers there and then just subtract the difference. If I have 45 and I take away 20, it's going to be 25 or whatever it is. You just need to look at your numbers and plot them accordingly and just write yourself a little note. This is a 20, this is 30, wherever it happens to land, kind of like I did over here. I wrote down a 3. I counted over. So how many times would you have to count over? Just keep working the problem and you're going to do fine. And we're back. So again, you're going to plot your vertices and then they're asking you to find the area. Use the formula for area, whatever your shape happens to be. So number 16 is you're finding the area of a shed. And again, just draw yourself a little picture if they don't allow you to do it on the screen. Draw yourself a little picture and plug in your numbers and see what shape you are. Whatever shape it is, use that formula. Number 17 is intentionally meant to confuse you. When you look at this question, you look at it and you go, it's intended to be like that. So they've given you all these numbers to freak you out. Don't get freaked out. You make a photo crop by cutting rectangles out of a parallelogram shaped piece of wood. So basically, the entire outside area is the parallelogram. You're cutting a piece out of it to make the shape of the prop for the photo. It's kind of like those pictures where they put people's faces in the prop. Maybe there's a surfboarding, or maybe they're out on the lake, or whatever. So you're going to put your head in that portion, or somebody's head through there, so that they can take a really cool picture. Okay, so I'm going to do the first one for you. Parallelogram, we know is length times width. 6 times 10 is 60. And then this little area right here is the area that you're going to stick your face through. This is the area that will not be needed to be covered in anything because it's going to be just a big hole. 4 times 3 is 12. 60 minus 12 is going to give us 48. So we know this is one of them. I'll give you a clue. There are 2 more like it. Okay, so a triangular talent has a base of 2 inches and a height of 3 inches. So I don't have perfect tools that I can stretch out, but I did make a triangle that has 2 for the bottom and for our bottom base, and then we go up 1. Oops. And again, I don't have the perfect tools, but this is my base here, and here's my height is 3. So they want to know what would happen if we doubled this. Well, what's twice as big as 2 would be 4. So we're going to do 1, 2, and again, you can just do this at home. You don't even have to do fancy triangles like I'm doing. You can just use your pencil and draw one triangle that has 2 at the bottom and draw another triangle that has 4 at the bottom. But this time I have to do double. So if I'm going up here to 3, twice of 3 would be 6. And I'm doing this to show you what it would look like. So I've got 1, 2, 3, 4. And again, I don't really have the tool to stretch out my triangles, but I can just add a little fluff here. So I can kind of see what twice the area would look like. That's what they're asking me. If this piece is this, how much is this going to be?